Alright, here we are on lesson 4, writing sums as products and products as sums. So the first thing we're going to work on here, it says rewrite the expression as a product of two factors, okay? So this keyword here is factors. For this, we are going to be using the GCF, alright? And we are using the GCF to factor out something, alright? So you can write yourself a note, this is like factoring out using the GCF. Okay, so if we look at part E, it says 72t plus 8. So we're looking at the GCF of 72 and 8. So the greatest common factor would be 8, right? So we're going to take that 8 out. So we're going to divide both of those terms by 8. Alright, so out in front we have factored it out. It's out of there. So then 72 divided by 8 would give us 9, and then we have t, and then plus 1. Alright, so we have written the sum as a product of two factors. Alright, if we look at G here, the GCF of 36 and 72 is 36. So we're going to factor that out. So we'll have 36 on the outside. We've taken it out. So 36 divided by 36 gives us 1z, plus 72 divided by 36 gives us 2. Alright, in I we have 3r plus 3s, so the GCF of 3 and 3 is 3. So we're going to factor that out. So we're taking out a 3, so what's left over here would just be an r, plus what's left over from here would just be an s. Alright, on F, we have 55a plus 11. So the GCF here, if we're looking at 55 and 11, would be just 11. So we're going to factor that out. So we're putting it on the outside. So when we take 55 out, or 11 out 55, then that means we have just 5a plus 1. Alright, in part H here, our last one, the GCF of 15 and 144 is only 3, so you might have to do some long division here to find out what 144 divided by 3 is. So 3 goes into 14 4 times, minus 12, we get 2, bring down the 4, and this would be an 8. So if we factor out a 3 here, we would have 48q minus 5. Alright. In exercise 2, it says write the product and sum of the expressions being represented in the rectangular array. So I'm going to fill this in, so write it down. We have a rectangular array here. 2x in the first box, 12y in the second box, and then 8 in the last one. So this is just kind of a little reminder if it says to write the product and the sum. So first, if we write the sum, we would have 2x plus 12y plus 8. But now, if we need to write it as a product, that means we're going to factor out the GCF. So the GCF here is just 2. So we're putting 2 on the outside, parentheses. 2 divided by 2 is 1x. Plus 12 divided by 2 is 6, so we'd have 6y, plus 8 divided by 2 is 4, so we'd have plus 4. So that is writing as a product of two factors. Right, part B here says factor 48j plus 60k plus 24 by finding the greatest common factor. So the GCF of those three, if we look at them, would be 12. So we are factoring that out. So we're taking the 12 out. 48 divided by 12 is 4, so we would have 4j, plus 60 divided by 12 is 5, so we'd have 5k, then plus 24 divided by 12 is just 2, so we'd have plus 2. Alright, so we're going to flip over to the next page now. And this says for each expression, write each sum as a product of two factors. Emphasize the importance of the distributive property and use various equivalent expressions to justify. Okay, so they want us to write it as a product of two factors. That means we're going to factor something out. So here we're looking for what they have in common. So in part C, both terms share a 3, so that's what we're going to take out. So we take out the 3, so that means we are only left with 2 and then plus 5. Alright, I'm going to work my way down here first. So if we look at F, we look at what they share. That's going to be like their greatest common factor, and here it would be 3. So again, we're going to factor that out. So here we would be just left with x plus 5. And then in I, same thing. What do they have in common? They both share a 3, so we're going to factor that out. And then we'd be left with x plus y. If we go back up here to part D, we're looking for what they have in common. Okay, so they all have 2 plus 5 in parentheses. So if we were to take that out, we'd have 2 plus 5, alright, and then we would be left with 1 plus 1 plus 1, right? So we could just write it as 3 times 2 plus 5. Excuse me. In part G, same idea, they all have an x plus 5. So if we add them up, there's 3 of them, right? So we would have 3 times x plus 5. Part J, same idea, they all have an x plus y, so it's the same thing, there's 3 of them, times x plus y. Right, part E is a little trickier. We're going to have to simplify first here, I think, to see anything. So we would have 4 plus a 7 plus a 10. Alright, so now we can regroup these. If we move the 10 over, so we have 4 plus 10 plus 7. Alright, we're trying to get something to factor out here. So if we group this and put parentheses around it, we can take out a 2 from both of them. So we'd have 2 plus 5, then plus the 7. And then we know the 2 plus 5 is 7, so we have 2 of that plus another one. So finally we would get 3 times 7. Alright, and I know that's a little tricky when you have all numbers. It looks a lot nicer when you have some letters mixed in. So let's look at H. We have 2x plus 5 plus x plus 5 times 2. So if we simplify, we have 2x, we have 2x, no, we'll just keep going, plus 5 plus x, and then 5 times 2 is 10, so plus 10. So now if we combine like terms, we end up with 3x plus 15. So we can factor something out of both of those. That would be a 3. So then we would have x plus 5. And that's a product. That's the writing the sum as a product of 2 factors. And then lastly here for k, we have 2x plus the quantity y plus x plus 2y. So if we get rid of those parentheses, we have 2x, it's just plus y and plus x, and then plus 2y. And if we combine like terms, 2x plus x gives us 3x, y plus 2y gives us plus 3y. So if we look here, they both share that 3, so we can factor it out. Alright, and then we'd have 3 times x plus y. Alright. If we look down at example 4 here, we've got a word problem. And it says, a new miniature golf and arcade opened up in town. For convenient ordering, a play package is available to purchase. It includes 2 rounds of golf, 20 arcade tokens, plus $3 off. There's a group of 6 friends purchasing this package. Let G represent the cost of a round of golf and T represent the cost of a token. And it says write 2 different expressions that represent the total amount the group spent, and then explain how they're different. So I'm going to write this down just so we don't forget. We know that G is a round of golf, and then T is the cost of a token. Alright, so there are 6 friends, okay? So keep that in mind. But first, let's work on using these letters. So we know that the package is 2 rounds of golf, so that would be 2G plus 20 arcade tokens, so it would be 20 T. I don't like that they use the letter T. And then there's $3 off, so that means we'd be subtracting 3. So now one way we could write it to find the total cost would be to multiply all of this by 6. Alright. Or we can distribute the 6 in, so we would get 12G plus 120T minus 18. So the difference is that the top one is more of the individual cost, and the bottom one would be the total cost of all 6 people. Alright, the first one is a factored form, and the second one isn't. That's also another difference. Okay. One more page to flip over to. On page 11, we're just going to do the top 3. Alright, exercise 5 says, what is the opposite of negative 6v plus 1? So we're thinking the opposite, right? Think of it, there's a positive sign in front here. There's a plus. So if we took the opposite, it would be negative 6v plus 1. So now it says, using the distributive property, write an equivalent expression. So this is kind of like what we've been talking about. You're thinking of this as a negative 1 here, so you need to distribute it. So negative 1 times negative 6 would be positive 6v, then negative 1 times positive 1 would be minus 1. Again, we just changed the signs. Alright, and the last one I want to do here, it says rewrite 5a minus the quantity a minus 3b in standard form. So, standard form is making sure that you have combined like terms, that they're usually in alphabetical order. So we need to distribute this negative. So that means we'd have 5a, then minus b, and then a negative times a negative would give us a positive 3b. So the last thing we need to do is combine our like terms, so 5a minus a would give us 4a, and then plus 3b, and this is our standard form. Alright, this is all we're going to do for now. I want you to bring in any questions you have tomorrow, and we will go over those all together.